Hey everybody, thank you so much for coming to our monthly community meeting here at the Dagster core team. For those of you who are new here, we have these on the second Tuesday of every month. And it's just a space for the Dagster community core or Dagster core team and the community to get to know each other, present about what they're working on, and as for us to communicate new ideas to you. So today we have three presentations on the agenda. First up, we'll have Simon from Rohde Schwarz, who will give a presentation about how Rohde Schwarz is using Dagster in production. Next, we'll have Sandy from the Dagster core team present a set of approachability improvements we've made in the last release that make it easier to use Dagster. And finally, Sandy will also present what's coming up in Dagster 0.12.0, which we're planning to release at the beginning of July. And finally, we'll have some time today for a Q&A. So please prepare any questions you have that you'd like to ask the core team. Without any further ado, I'd love to invite Simon to present about how he's using Dagster.
Thank you very much. So I hope you can see the slides. Okay, hi and welcome. Thank you very much for having me. My name is Simon Späti. I have the pleasure to show you today how we use Dagster at Rohde Schwarz, mobile network testing. A little bit about myself. I'm a data engineer. I'm an author of my little blog where I write also about data engineering stuff, and I'm an early user of Dagster. Rohde Schwarz is a big company. We have over 12,000 employees around the world. We specialized in electronic test equipment, broadcast and media cybersecurity, radio monitoring, and all kinds of radio communications. I'm located in Switzerland, where we work at a product called Smart Analytics. This is it's actionable benchmarking, so you can compare different network providers to each other. You have kind of a business intelligence overview to really see the mobile network testing quality, so you can see how is my network doing compared to my competitors, where can I improve, and where is my bottlenecks in my network. And as mentioned, my blog where I write about the data ecosystem. To go a little bit more in detail what we do. So our main goal is to provide the tools for our customer to improve the quality and performance of the mobile network. So on the downside, you can see the car. So this is the mobile network testing in Africa. So there is not always streets, but we have equipment that you can see on top of this car. There is actually, we put all of our smartphones in there. So we have a QualiPOC, which our software is running on. And you can either put that in a car or you can also put it in a backpack. So if you would like to measure the network quality in, for example, like in a metro or in a football stadium or so, then you can use the backpack, put in the smartphones, and then configure what kind of test you would like to do. So we can configure like YouTube test. The phones, they will call each other. They will call WhatsApp calls. They will upload to YouTube. So they will do all kinds of different test scenarios that hopefully the real user will also do. And then at the end of the day, you get a measurement file, and then that gets uploaded in our Smart Analytics. In our Smart Analytics, we have like a time series and statistical. So if you look at the architecture, this is actually the testing going on. So during the day, several cars, several backpacks are collecting these measurement files. And then typically during night or in the evening when you finish measuring, you upload it to our data warehouse where our custom ETL is running. So this is where all the magic happens, where the data is transformed into fact and dimensions. We clean the data, we transform them, we aggregate, and then we put them into the SQL server for the time series analytics. So if you really want to drill down into the, let's say in the protocol level, what happened when a call has dropped, why it has dropped, So that's where you use the SQL Server, or also if you want to plot the points, so the measurement points on the map, you would typically use the SQL Server. And then we use the analysis service where this is our cube. So for statistical reasons, there you can have overall statistics, how your network is doing compared to your competitors, what tests you have actually measured, how long, and yeah, all kind of statistical measurements. Yeah, and then the motivation for us for using Dagster. So we want to bring this ETL into the cloud, and we would like to manage all this logic or this ETL logic in a central place, and also being big data ready with in the cloud. As you know, there's a lot of open source tools which you need to mingle together, and there we just want to be ready to connect all of these tools and also have like a state-of-the-art tool. So as said, from on-premise, we went to the cloud. We also want to scale out. So at the moment we have SQL Server that can only scale up, meaning we need to buy a lot of expensive hardware in case we have a lot of data, which costs a lot, especially if you have idle time. So you pay the cost anyway. So, and in the cloud, we want to use more cheaper machines and only scale up if we really need the resources. So we can really also scale down and save money when we don't use any kind of ETL or only limited amount of queries. And then generally we want to also overcome the ETL processing because that took longer and longer, especially for our big customers. They're collecting more data, and also with the 5G and 6G in the pipeline, there is coming more and more data, which we need to be ready for. And also query time, we have a lot of percentile queries, or medians. So in that matter, you really need to sort all the data to find your median. And that, of course, you know, when the bigger the data is, the longer it takes. And there we really got on the limit for bigger data. We also have a web UI, as you've seen before. And there we really need seconds response time. So the user they want to have this dashboard kind of feeling where you really drill and slice on the fly and they don't have time to wait. So we need a really fast response time. That's then how we look at our architecture today. So we use the browser for accessing our smart analytics. Smart Analytics is then is an in-house built tool with Node.js, Angular, and C# backend. We also have other query types like Tableau. So users or our internal users can also use Tableau for querying the data directly. We have Jupyter notebooks to do ad hoc analytics or machine learning models. And then the measurement files, the ones that we talked about before, they get uploaded directly in our S3 storage. And there we ingest into our data warehouse, which is Druid. Apache Druid is our replacement for our cubes. So it is well suited for us because it has a sub-seconds response time, also on large data sets. And it also, the architecture is made that you can really differentiate the ingestion to the query time. So even though we would load a lot of data, the query time is not interfered at all. So this makes it a really, really good choice for us. We also use Spark for processing the data and also creating delta tables. We have general service in our Rohde Schwarz cloud. We use Kubernetes for that. And then there we get like monitor logging, resource scaling we get out of the box. And then of course, the heart is Dagster, where we really put all our code into. So the import pipeline is mainly based on eventing. So we use a lot of event-driven pipelines. So if the customer uploads files, it gets triggered pipelines. And then from there, we use other sensors or events that take it to the next pipeline. We also have a so-called adoption layer where we do the data processing. Let's say if we have a version upgrade or we do other calculation or machine learning models, that's done in this bucket here. As mentioned, the sensors is a big part of it. So if you have never used sensors in Dagster, this is how it looks on the Dagit UI. So it's very nicely done that you can really see all the dots. That's actually when you trigger a new sensor. So there you can say how many off or how often it should poll, and then it would check some kind of Python logic, and then yeah, we'll start some jobs so you can see which got spawned, and then you can really click all the pipelines and see which pipeline has been started. So this is from the UI perspective a very nice way, but also if you implement this, so the only thing you need to do is actually to put an annotation at sensor and name your pipeline you would like to start. And then for us, it's very handy. We use S3 mostly with sensors, and there we can build in some glue logic. So we define which files we would like to read. You could also add more logic, and then we just spawn pipelines out of each file. So this is a nice way to add a little bit glue code there, and to spawn your pipelines event-based driven. This is, let's say, our import pipeline, just to give you an overview how this looks. So we don't have like an overall pipeline, as mentioned before. If we upload our zipped files, sensor get triggered. It will like parallelize per file that get uploaded. All of the unzipped files get uploaded again. And then we take a next sensor that takes each of this file individually and run the ATL pipeline on it. So we really try to scale as much as possible. That's also why we use sensors, because we have different granularity between these sensors or pipelines. This ETL pipeline will then do all the logic which we had before. So we have our facts and dimension coming out here as a Parquet file. And then this gets, based on fact tables, gets ingested into or created as a Delta table on our S3 storage. And then we also with Python ingest it to Druid. So we have a very nice flexibility that we have machine learning use cases or the experimental stuff. We can really use the Delta tables. We can also do joins and more sophisticated things, whereas in Druid, we really use for our sub-second response time for the application. This is the pipeline part, but we actually also use Dagster for provisioning. So whenever we have a new user or we have a new tenant in our cluster, we use Dagster to create the buckets, to upload the secrets to our vault. We create the Druid account. So the more we use Dagster, we also find new use cases that we can actually integrate with it. So it's not just for data pipelines that which is very powerful for us, but also for other kind of administrative tasks that we would like to automate. Exactly. And then we also use assets. So assets is the part where you link your data to the computation. So it's also maybe a rather newer feature, but it's very well suited for if you want to add metadata on, or you also want to show your persistent data to your customers. So we played around with the ETL. So we added some size or durations to it, and then we could immediately see if there was a spike in some ETL jobs, or then we could actually, you can then on the UI, you can also click on that point and really drill down to the actual pipeline to see which file it was and what happened there. So this is a very nice feature for us, and we would also like to add more. So we try to create assets for all our persistent Druid tables and also for our Delta tables. And in the future, we also like to try the data lineage that just got added to Dagster, because we have this event-driven pipeline that from the zipped files to the actual Druid fact data table. Sometimes we have some wrong data, and then it would be nice to see where this data is actually coming from. And there we were hoping to use the data lineage feature to actually document it and also make it available for all our customers and also for us as engineers. If you haven't used assets, it's actually quite easy. The only thing you need to do, if you have your solid, this is the one part of your pipeline. Beside yielding your output, you just yield another asset materialization, and this is actually exactly what we do here to get the output that we just saw before. So we just add a key, which is the unique identifier. So here we are still playing around if we want to have it on each fact level, or we would like even to have it a little bit higher level. And then Dagster is like dividing it, but here you can add descriptions and then all the metadata, which we have seen before. So, so far, we use it, let's say, for quite a bit. And the advantages for us using Dagster is, in the first place, also that we could replace our custom-based processing engine that we used on-premise. But now we have massive out-of-the-box features. So we just have restart capabilities. We have backfill. We have the dependency management. Yeah, we see what's job. We have the UI. So we have different modes. So you can just switch from production to local. Just you have these modes that you can just switch. So all of these features are tested and stable. So we just get them out of the box. So this was a nice implication for us when we start using Dagster. The beautiful Dagit or the UI is very nicely done, and it's shows exactly what you need to know. You see always the state of each pipeline, what is the current jobs running, and you get rich metadata. That's also a big plus for us, that we can really add also customized metadata to make available in the UI as well, easily, without doing too much. The problem solving is also a big thing for us. Before we used other methods. Sometimes it was actually hard to find the error itself. So we had to go through Kafka pipelines, or we had to really find the error. And sometimes we couldn't even find it. So with Dagster, you really have the error straight in your face. So you really, you can really start solving errors, because, and in case you miss some data or you don't know why the error happened, you just add more meta information. So at the end of the day, you just have an easy way, or always have all meta information to solve these bugs. We also have users or developers that didn't come from the data sphere, and they have told me that it's easy for them to grasp the concepts. So all the concepts with the resources and the solids and the pipelines, it made sense to them. So we could also have quite fast speed up with new developers using Dagster. And it's actually very pleasant to write pipelines when you have such a nice framework around you with, there's a lot of thoughts in it that you don't need to think about. It's just built in. And then everything is self-documented. So you don't need to actually like draw diagrams anymore, because the pipelines in Dagster are self-documented. You can really see each steps. You can even put SQL statements inside there to really see what's actually going on with the assets as mentioned. And you're spending less time actually explaining what's going on, but you can really discuss business transformation and logic, what needs to be done. One of the biggest thing for me was the reusable of code. So once we had, before we had microservices in Python. So first things we could really easily move them to Dagster. So we had classes, and then we just added them to resources, and then we already had them inside Dagster. So that was a very elegant way to use existing code. So for us, it was in no time we could move the stuff. But also the resources are specifically helpful for us, because you write the code once and then it's tested, and you can use it everywhere in the solids or in all your pipelines. So you don't duplicate your code. It also reduced the boilerplate code for us, because when you have microservices, you tend to integrate the logging, the restart, and so on. These kind of things you always need, but you always re-implement them normally when you have different microservice, but with Dagster, you do that once, or you even get it already out of the box, or you build it yourself, but then you do it once. And that was very good for us. And it's also functional by design. So when you use Dagster, all the pipelines are actually built functional, which also reduces management or ease up the maintenance of code or restartability. And all of this comes just out of the box just by using Dagster. Here is an example of how we use resources. So for example, we have a Druid resource. We took our classes that was already there, the Druid connector, with some methods that we use. And then you just add an annotation, add resources. And then you give it all the passwords and usernames it needs. And then you do that exactly once. And then you can use it in your pipelines just by specify the resource. And then you can access this with the context. So the context is very powerful. So all resources that you specify, you can just with context resource.druid, you have access to all these resourced methods. So besides that, the context also has additional functions that you have, for example, the run ID. So you really get a powerful tool there, and you don't need to fiddle around with passwords and usernames, because this you do once in the resource, and then you're ready to actually do the pipeline logic, which is is also another very nice feature of Dagster. When we started, there wasn't yet the Kubernetes deployment, but just when we were about to start with Kubernetes, actually there was, and so we are heavy using Kubernetes. It's also very handy for us because we have a SQL server on Linux in one deployment, and in another one we use Spark. So it's easy to separate them with the user codes, and we can also scale out easily with new pods. And it makes things very easy for us, and also understandable what's going on. And that's also a big plus for us. It's Python based, so the language of the data nowadays is Python, so it's easy to learn and to adapt for engineers. And it also supports SQL statements, so you can have your solid that takes SQL statements, and then you can easily integrate that as well. Or it has also powerful extensions like dbt and other things that you easily integrate with it. So, and that's this. And the next steps. So we're not yet using that much unit testing and smoke tests, so we would like to improve there. At the moment, there's a lot of manual testing, and we would like, of course, to have some test files that automatically get tested. The documentation, we would like to use assets more intensively, maybe even automated. Integrate the data lineage feature. We started some Dagster pipeline guidelines just to have some best practices around the, let's say, when to use assets, what is the namings, how to use resources. So it's very basic, but we also like to start growing that one. And specifically, I would also like to try the dynamic orchestration. As told before, we have many sensors starting low-level pipelines. But with, I would like to try if we can also use maybe one pipeline that spawns dynamically all the sub pipelines. And also partitioning, we're not using yet. Everything is based on files in our environment. So partitions would make sense there as well. Yeah, that's it from my side. Just contact me anywhere if you have some question, or feel free to ask them later on. Thank you very much.
Thank you, Simon. I also wanted to give Simon a special shout out. He was an extremely early user of Dagster and has produced a ton of great content about using Dagster on his blog, which I highly recommend everyone here to check out. And we'll also have time for questions for Simon at the end of the community meeting. So next up we have Sandy from the Dagster core team. Sandy, are you there? It looks like Sandy's computer is frozen, so we can actually maybe have some time for questions for Simon right now. If anyone has any, feel free to drop them in the chat or unmute and ask directly.
It's späti.com. Right, I can choose.
I will give Sandy just a minute for his computer to come back. We can also do general Q&A earlier, now that we have time. So if you have any questions for the Dagster core team, please feel free to ask. Oh, we have Sandy. Great.
I'm back. That was terrifying. My computer just froze right before I was about to talk. Okay, but I'm excited to be speaking to you. I'm going to share my screen in 1 second. Okay. Cool. Okay, my name is Sandy and I'm an engineer on the Dagster team. I'm going to talk about a set of improvements that we made to Dagster's core APIs in the last couple of months. So people tell us a lot of nice things about Dagster, but one of the more persistent pieces of critical feedback we've gotten is that it can feel very heavyweight. Dagster has a lot of concepts. So these are some screenshots taken from our doc site. When you're doing complex things, you often need complex software, but being confronted with 20 different abstractions when you're trying to get just a basic pipeline set up is more of a hindrance than a boon. So one of our aims recently has been to make Dagster better at progressive disclosure of complexity. What progressive disclosure of complexity basically means is that doing simple things should feel simple. When you want to do more advanced things, you need advanced concepts. Those concepts should show up just in time. The second area where Dagster can feel heavyweight is boilerplate. So previously, this was the code you needed to write if you wanted an argument to a solid decorated function to include a Python type annotation for a non-built-in type. You had to write this word series, which is the type that you're trying to annotate, 3 different times. So there are a bunch of other situations where you end up needing to type a lot of characters to get something pretty simple done. We want to make it so people developing on top of Dagster don't need to put the same information in multiple places. And we want to make it so that they generally just don't have to type a bunch of characters in general. So one caveat here, of course, that we don't want to make things too magical. It's always possible to go further in reducing boilerplate, but at some point, clarity can suffer as well. So I'm going to highlight improvements that we made in a few different areas of our APIs. One of the areas is the relationship between Python types and Dagster types. We built Dagster types to help developers write flexible runtime checks on the data that's passed between solids. This is a capability that we think is really important. So we describe Dagster types as gradual, but historically we required users to engage with them in some situations where the user is trying to do something other than just write a custom runtime check. With the recent changes we've made, it's now possible to use Python type annotations without dealing with the Dagster type system. So let me show you what this looks like. This is a code snippet that Dagster had raised an error on until recently. In it, someone is trying to include a type annotation on the argument to a solid decorated function. They're trying to say that this input should be a series. Dagster used to raise an error on this because it tries to find a Dagster type that corresponds to the series type, which is just a regular Python type, and can't find one. To get that to work, you had to do something like this. So this is the example I showed on the intro boilerplate side. What's happening here is that we're constructing a Dagster type that corresponds to the series Python type, then registering it globally so that Dagster understands that correspondence. With the recent changes, you don't need to mess with Dagster types when all you're trying to do is express the Python type of an input or output. You can just use the Python type annotation. Behind the scenes, Dagster wraps it in a Dagster type, which means that it can show up in Dagit and also be checked for that type at runtime. So this kind of brings up the more general question of like, when should you use types? And basically, if you want to express the Python type of an input or an output, just use Python type annotations. Don't feel like you need to mess with Dagster types. If you want to define custom checking logic for an input or an output, like write some function that validates it in some deep way, use a Dagster type. A related change is that you can now provide an input definition for one of your inputs without being required to provide input definitions for all of them. So in this example, we want to add a description for our first input, but we don't care about doing that for our second input. Previously, Dagster would raise an error here, but now it does not. So another place we've tried to improve Dagster's progressive disclosure of complexity is with config schema. Historically, if someone wanted to provide configuration to a solid in their pipeline, they would need to provide a value for the config schema argument on the solid. In addition, all of our examples highlighted the strongly typed aspects of our config system. So here it's strongly typed because we're requiring the config to be specified as a string with a given key. It's actually possible to be more permissive and provide a value of any as the config schema type, but we didn't really encourage people to do that. So we observed that for many people, this was a lot to deal with when learning the system. They need to understand how config schemas work and the type system for config schemas just in order to do basic things. Even for Dagster experts, it can be annoying to need to provide detailed config schema when you're just trying to prototype or when passing a blob of data with a complex structure. So we made a small but fairly significant change, which is to make the default config schema type the any type. What this essentially means is that now you can provide config to a solid without needing to define a config schema for it. This is to say that the code example on this slide now works. We pass configuration to our solid without explicitly setting a config schema anywhere. We just apply run config when executing the pipeline and the solid can access it. So when should you use config schema? We still believe that it's wise to use config schema for any solid and any configuration that you're putting into production, because catching errors early saves lots of time in the long run. But when you're prototyping something in development or when teaching Dagster to someone new, it can often make sense to omit it. Stepping back a little bit, one of the things that can feel intimidating about Dagster is the emphasis on config in general. So newcomers to Dagster are often led to believe they need to heavily factor their logic to make use of the configuration system. Overuse of config can result in kind of like sprawling YAML documents for relatively simple pipelines. So here's a pretty intense example of heavily factored config. This is an early version of one of our own demo pipelines, and there's tons of redundant information that really can and should be constructed in code. So on our latest doc site, we've tried to clarify and publish guidelines on the situations where config is appropriate. In general, you should use the config system when you want the person or software that's executing a pipeline to be able to make choices about what the pipeline does at the time that they're launching the pipeline. So for example, maybe a pipeline processes data for a particular date, and you want the person launching the pipeline or the schedule launching the pipeline to be able to parameterize the behavior with that date. Maybe it's operating on a particular file, and you want a kind of like self-service interface where less technical users in your org can come type in the path to a file and process that file. And config is kind of perfect for that scenario. So another area we tried to streamline is event metadata. Event metadata is the kind of metadata that you can include on events like asset materializations. And the metadata then gets nicely displayed in Dagit. The changes we've made here focus on boilerplate elimination. So here's an example of an asset materialization that includes 4 metadata fields. As you can see, it's quite a chunk of code.
This one is that Dagster has a monthly community meeting, which is happening at the moment.
Do you have a question? Okay, I'll continue.
Dagster is having a...
So here's what you can do now instead. Instead of a list, you can provide a dictionary. And for primitive types like floats and ints, you can just provide them directly instead of needing to construct a wrapper object. Last of all, we shortened the name of the argument. So taken together, these changes might seem small, but you actually get a quite less verbose API, which hopefully lowers the general friction and threshold that's required to include any metadata, which hopefully encourage you to log more metadata so you can look it up in Dagit. And last, but certainly not least, the context argument on solid decorated functions is now optional. So you only need to declare it if you need to use it. In this example here, we have a couple of solids that don't use their context argument. All they're doing is returning a value or taking some inputs, adding them together, or returning a value. Now they can be rewritten to not even have a context argument. Dagster recognizes the name context and knows to treat it in a special way. We never allowed solids to have inputs with that name, so this is not a breaking change. This, of course, doesn't mean the context argument is no longer available, so you can still use it when you need it, like in this example, where we're accessing the config via the context. So the context change really shines in combination with another change that's not here yet, but is on its way. Currently in Dagster, if you want to execute a solid, for example, on a unit test, you need to do something like this. So you invoke a function called execute solid, which executes your solid and gives you a result object, which you can then pull the output value from. It's not terrible, but it's a lot extra to type every time you want to invoke a function. We're working on changes that will allow you to just treat the solid like a regular function and execute it like this. If your solid requires a context object, you'll be able to just create a context and pass it in. Note that we're still finalizing these APIs, and they might end up with a slightly different name when they make it into release. But here we're creating a solid context, and then we are directly invoking our solid that's called operate, passing in that context, and then passing in the inputs that are expected by that solid. Direct solid invocation is useful in a few different situations. So if you're writing a unit test, there's less boilerplate. Same thing if you want to invoke your solid from inside a Jupyter notebook. If you're just trying to experiment and directly invoke some of the components of your pipeline, you don't need to wrap it in a bunch of boilerplate. And then third, it becomes easier to switch back and forth between making something a solid and a regular function. So you won't need to change all the call sites if you decide that a function should actually be a solid or vice versa. So I'm going to shift gears briefly, last of all, and talk about a couple things that we're working on that aren't related to approachability. The first one is comprehensive failure notifications. So far, Dagster has solid hooks, which allow you to trigger some logic if a failure happens inside one of your solids. This isn't sufficient because there are lots of things that can happen outside of a solid that might cause a pipeline to fail or not even run at all. And if you have a production pipeline, what you care about is whether it runs, not the particular place that, the particular thing that's causing it to run or causing it to fail. So for example, you might encounter a fail while launching a run. You might encounter a failure while validating configuration for a run, or even inside a scheduler or sensor function before the run has been launched at all. We're still exploring what the solution space looks like, but ultimately we want to make it easy for you to write code that executes anytime that one of these unexpected things happens. The second thing we're looking at is making it easy to understand the relationships between pipelines. So there are a couple different ways that we might say a pipeline depends on another pipeline. One is that a pipeline might consume assets that an upstream pipeline produces. And another one is that a pipeline might have a sensor that triggers it when an upstream pipeline completes. In situations where you have a lot of pipelines, it can be difficult to get a handle on how they all relate to each other. So we want to make it easy so that it's easy to basically understand your entire organization's graph and not just the subsegments of those graphs that live inside individual pipelines. So these are two of the features that we're targeting for our 0.12 release, which will land sometime in July. We have a few other areas that we're interested in as well, but we haven't sort of defined what the direction looks like quite as much. So we're interested in your feedback on what's important to include in our upcoming release. You can, then we're gonna have some extra time for questions, so you can sort of bring it up directly here in this conversation. Or if you think of something later or just more comfortable typing, the Dagster feedback channel is a good place to put it. So yeah, thanks a lot. That's all I had.
Thank you, Sandy. So yeah, the rest of the time is open for questions. So please feel free to speak up or just leave a question in the chat and we will get to them. Sandy, do you want to take that question?
Alex, are you here? Because you've been doing some retries work recently.
Yeah, we are exploring what the right way to set this up is. So we don't have anything definitive, but there are some prototype diffs out, at least for the solid level. And then I think the piece that Sandy mentioned, the same system that will back these notifications for like pipeline level failures, will probably have some means for doing pipeline level retries. So we're working on it. Nothing super definitive to talk about at this point.
Is the 0.12.0 release going to have a cool code name? Yes, it will. It hasn't been finalized yet, though. Alex, you want to take this one too?
So this continues to be, so the question is, what's the latest in the @graph operator to replace composite solids? It's a great question. We spent a lot of time discussing how to manage this. We currently have, a different approach that we're exploring. Maybe Sandy would like to speak to. Sandy, why don't you just kind of give your current pitch of where we're at? So basically, this is really tricky, right? We want to try to simplify. We currently have the setup where there's pipelines, solids, and in between we have this composite solid, which allows you to like kind of make a pipeline that you can embed in other pipelines. It's a weird space. We're not happy about it, but the different approaches we've explored so far to solve this problem none of them have really like made us very happy, because there is some significant amount of change that users are going to have to go through here, since we're changing one of like the core things in the system. So we've continued to like spend a bunch of time, kind of get close on something and decide it's not quite good enough. And so Sandy's been leading the charge on kind of his current vision for where this could go. So I'll let him speak to this a little bit.
Yeah, so for those who aren't familiar, I think one of the main threads that sort of we pulled to get at this problem is essentially that we have this thing called pipeline and this thing called composite solid, and they function very similarly. In other words, they both contain a graph of solids, but they're two distinct concepts. And this can be confusing for a lot of people and sort of adds extra overhead to understanding the system. So our question was basically, can we consolidate them into a single concept? And the kind of primary obstacle that we've faced when trying to do that is modes. Because if you have a pipeline with a set of modes, and then you want to embed that pipeline inside of another pipeline or composite solid, what is the meaning of that? Do you get this sort of like combinatorial explosion of modes as you go up the tree of pipelines? So what we're investigating right now, and we haven't committed to any direction, is basically a direction that would sort of allow us to take modes out of the equation in those situations. So that putting pipelines inside of the pipelines or graphs inside of the graphs, depending on what naming we decide to go with, doesn't face that same issue. And it would also dovetail with a set of changes that we're considering independently, where it can be awkward to be required to define all the full set of modes on a pipeline up front. So for example, if you want to inject particular resources inside unit tests, that's very awkward in Dagster right now, because the pipeline definition itself is required to basically hold all of the resources that it's allowed to execute with. So we're considering changes that would allow you to define a pipeline without defining the modes on the pipeline, and then supply those resources or that mode later on.
Sandy, do you have context for the next question as well?
I think this might be a better Alex question.
Yeah, so the question is about launching pipelines from Python. Currently, Andy here is talking about they use the execute launch command, which is the entry point for our CLI to do launching. And we're wondering if we're going to have an async function to do this as per discussion. So this is something that we explored a little bit. last release related to some other changes in the testing APIs, which was also connected to this graph stuff. So we're thinking about like having an execute graph command and a launch graph command, and like what's the right way to target something for launch. So we've explored this a bit, but we don't have anything ready quite yet, I guess is the short answer. Not super definitive, unfortunately, but so we've explored this and some more work to do on figuring out exactly what the API for this should be.
So I'm looking at the next question, which is in reference to modes, discussion, and resources, would that include mapping expected to supplied resource names so we're just under less of a global namespace that needs to be managed? I think would you mind talking a little bit more about what you mean by expected to supplied resource names? Like, is the idea that you'd like to be able to supply resources to particular solids without supplying them to other solids in the same pipeline?
No, what I had in mind was, this is Chatai, by the way. Hi. Is that, like every resource in a pipeline that requires a resource gives a name to that expected resource, right? And then that's something that you have to supply to the solid when you configure the pipeline. Both like in terms of configuration and when you set up the mode. And those names have to match. Like if you have two resources, if you have two solids that both need a resource named DB, but they're actually different kinds of DBs, but the writers of those solids like, didn't really think about coordinating the namespace, then you're kind of in a hard place. Except by changing those solids, and every config that ends up like, using those solids in your existing pipelines and production. Like that's, is there a way or at least like a direction to make that a simpler thing to solve? Got it. Okay, yeah, we definitely talked about that. We've talked about it as essentially like resource key remapping, where if you if I understand correctly, you have these collisions in resource keys, and you want to be able to say this resource key that this solid requires actually corresponds to a different resource key on the pipeline. Yep. We've done some investigation into this. Chris on our team has played around with it a little bit. To my knowledge, we haven't shipped anything yet. Adding an extra layer of direction makes a lot of things complex. And so we've been trying to be careful there. But it's definitely something that we would consider incorporating if a lot of people are facing it. Thanks. Okay, so the question was, how would connecting pipelines with different schedules look like in the graph world, in the world with the @graph decorator? Imagining pipeline A generates assets hourly, which should then be used by pipeline B, which runs on a daily schedule. So I think the design space is fairly open-ended, and we're considering a lot of options. I think to some degree, if you have pipeline A producing assets, and then pipeline B is consuming those assets, that is an inherent relationship between those two pipelines, and we'd like to be able to capture them. If I understand correctly, the two pipelines don't have a super tight execution dependency. So it's not like you want to kick off pipeline B every time that pipeline A kicks off. But there's still a relationship there, and so we would like to be able to capture and visualize that relationship.
wait a bit longer for any more questions to roll in. Cool. If there's nothing else, you can call it. Thanks again, everyone, for coming by. We'll be back next month on the second Tuesday of June. And if you'd like to speak at the next community meeting, please reach out to me or fill out the Google form that we had at the beginning of the presentation, and we can work with you to form a presentation. Thank you.